Okay. The next question is to do with probability and finding the likelihood that a number of things work. So Meg and Ravi buy sweet peas and grow them in identical conditions. The number of packets bought by Meg, number of seeds in the packet, so she's bought 100 roughly. And the number of plants she gets out is this. Ravi earns 10 packets with an average number of 20, or 20 in each. He gets 170 out. Using Meg's results and Ravi's results, calculate the two different estimates for the probability that a sweet pea will germinate. Now the estimates will be based upon the number of seeds we tried, as being the total, and the portion will be the number that actually germinated. So the total for this one is 100 seeds were tried. Here 200 seeds were tried. So Ravi has an estimate of 170 out of 200, and Meg has an estimate of, add them up, 35, that's 70, 89. 89 out of 100. That's sufficient for each mark. They just want an estimate for probability, nothing for us to compare at this point. Now we come into part B. This is where we need to actually have the probability and think what's going on with it. I would expect there possibly to be a question here sometimes which would say compare your results. In that case, make sure you get the same denominator. Ravi would have 85 out of 100 germinated, so you could say Meg had actually improved. So if we were asked to compare, Meg would have 89 out of 100, and Ravi is 170 out of 200, which simplifies down. In terms of 100, we want the same denominator as 85. So Meg had better results, or more plants grow. Okay. This question doesn't directly talk about that, so if you simplified this, it's unnecessary work and potentially could cost you the mark. Whose results are more likely to give a better estimate for the probability? Well, when we're talking about estimates, more tries is important. And who made more attempts? Ravi. So Ravi, he tried more plants, or more seeds. He tried more seeds than Meg. So theoretically, these are supposed to be the same, have the same rate. You were more likely to trust Ravi's results than Meg's, saying that her 85 out of 100 would germinate on average. Next question. A 3-digit number is multiplied by a 2-digit number. How many digits could the number have? Write down the minimum number and the maximum number of digits that the answer could have. Well, the minimum is quite easy. We think about the smallest 3-digit number we can have and multiply that by the smallest 2-digit number we can have. That gives me an answer of 1,000. Now, going the other way to the other one, you may be tempted to try to do 999,999. Oh no, we do need the maximum. So we need to do these sums, multiplying 999,000. Oh, they just want the number of digits. So this one needed 4 digits. If we went to the next one up, so we were doing 1,000 times 100, we know that we're going to get this extra 1 in front. So this would actually give me 100,000. That's 6 digits, but this 1 is extra. So a 3-digit number times a 2-digit number could have 4 or 5 digits. If you tried doing this 999 technique, you go 9, let's go 1, carry 8, 8 is 81, 9, carry 8, 81 plus 8 is 89, carry 8. Next number comes over, we go 0, and we go 1, and it's the same calculation. When you come to add them up, you get 1, 0 carries 1, gives me 18, 19, carry 1, gives me 18, carry 1, gives me 9, and there are 5 digits. If you made a mistake in here, but you showed the proper technique, you would probably get both marks. But this is a quicker way. We've used a slight overestimate. Okay. Next question. Solve these simultaneous equations using an algebraic method. That means you can't do any graphing and you can't guess numbers. So no trial and improvement. The two techniques we've got are we can do elimination, which is where you take one expression and you multiply one of them by a number or both of them by numbers to make coefficients the same. The obvious one here is to make, actually there's a choice of two, so I'll do it in both ways. If I multiply the second equation by 2, so I'm doing 2 times 2, in that case I will get 4x plus 2y equals 8. Subtract equation 2 from 1, and I get 0 x's, I get 1y, and that is equal to 13. With all of these, simple thing, if you take these and put them back in to find the other value, they should all give the same number. So for this one I'm going to go 2x plus 13 equals 8, so 2x must equal negative 5, so x is minus 2.5. Any other technique I use should give me the same answers. The other one for the same technique of elimination would be to multiply the second equation by 3, and this will eliminate the y. So we now have 4x, 6x plus 3y plus 3y equals 21, and it equals 24. And now when I do this, 8, 16, 24, that's there. Y, I've got an error in here somewhere. 2x, 5, 2.5. I forgot to multiply this by 2 here. That's 16. So when I subtract, it's 5. So y over here is 5. It's 8. So 2x equals a positive 3 equals 1.5. Okay, so I made an error, but I've caught it because I'm using another technique. Do check them. What I should have done was take both x and y and put them into the first one. 1.5 times 4 is 6, plus 15 is 21. That now works. Now do the subtraction for this one, and this time I'm going to do equation 2 subtract equation 1. By taking this one away from there, I get 2x. This 3y from this 3y is nothing, and 24 minus 21 is 3. So x equals 1.5. Put it into one of these two equations, so the second one again, which gives me 3 plus y equals 8, so y equals 5. Okay, same values. I'm writing them as set of coordinates because graphically this is the point where these two lines cross. The other technique is to rearrange one equation and substitute it into the other. So I could take equation 2 and rearrange it so y equals 8 minus 2x. If I substitute it into equation 1, we have 4x plus 3 times 8 minus 2x, and that is equal to 21. Running out of space. Expand the bracket. Plus 24 minus 6x is equal to 21. I'm going to do the subtraction now. I get minus 2x. 24 equals 21. I'm going to move the 2x to the other side by adding 2x to both sides, and I'm going to subtract 21 from both. And this now turns around and tells me that the x is equal to 1.5, and therefore I can now do the y. So y equals 8 minus 3, which equals 5 again. You can use either technique, it's up to you. You do not have to do any other, any particular technique apart from you're not allowed to use a graphical technique, and you're not allowed to use trial and improvement. Next video, next question. Last question on the 5 to 7 paper. There's another 7 questions on this 6 to 8. Last one on 5 to 7. This is a construction question. On a diagram, use lines A and B and C are straight, so there's A to B, A to C. Using compasses and a straight edge. The straight edges use a ruler, but you're not allowed to measure any lengths. Construct the angle bisector of the angle BAC. Bisector, I've got to remember that bi means 2, sect is equal parts. So we've got to make them into 2 equal parts. So we're looking for a line coming through this way. You must leave your construction lines in. It's important you do. You must show what your technique was to do it. Now I know the line's going to come through here, and I will take you through the actual one on a construction here. So all I'm going to use is my compasses. I'm going to do in pink as my construction lines, and if you remember about constructions, the rules you use with compasses are the point can only go in a known place. Now the only known place in this diagram is actually that cross point. These 2 end points could be anywhere. They happen to end at a particular place, but we're not told there's anything special about them, so we can't use them. We use our compasses and we adjust them. Make sure you work on a reasonably large size. Try and use your it helps improve with your accuracy. And what we're going to do is, remember, we're trying to create a mirror line between these 2 points. So anything I do on one side of the mirror, I need to do to the other. So put the point down, and I'm going to create a new arc, so I get a new point on this side. If I've done that, I need to make a mirror. There's my 2 points, either side of the mirror. The next part is to create a point that's actually on the mirror line, and that's by using these 2 points and trying to come back to find somewhere on the mirror line. Now, you can adjust them at this point. There's no need to, and most people don't. What we wind up constructing is actually a rhombus between here, and the diagonal of the rhombus is actually also the angle bisector. So I put my point as accurately as possible over there. I construct it, put the other point on that end, bring it round, construct the arc that side, and then I fill in, and I would tend to make this a little heavier than I did with my construction lines, and I draw my line through the point, and through the angle, and this point over here. If you are worried, get your compasses out. You can measure the angle. The angle I estimated on this one was about 72 degrees. When I constructed my line, half of 72 is 0 to 36 degrees. So I've done a perfect angle bisector. And that's the end of that question and the end of that paper.